Hi everyone, this is Srikar from Information Technology branch. Today I am going to explain the topic from of database management systems of title a greedy algorithm for task offloading in mobile edge computing systems. This was taken from the source of China Communications Volume 15 issued on November 11th of 2018. Today I Okay, the introduction part of our agreed algorithm and edge computing of a system is a modern mobile applications such as gaming, AR, and data analytics require high computational power, which mobile devices can't efficiently provide. Okay, and our mobile education computing enables computation to be performed closer to users, reducing dependency on distant cloud servers. Okay, and our uh, task offloading is used to transfer computation intensive tasks from mobile devices to edge servers for better efficiency. And our next slide is okay. What is mean by mobile edge computing? Okay, which shortly can be called as MEC. MEC is a computing paradigm that places servers at the edge of the network near base stations and users. It significantly reduced network latency compared to traditional cloud computing by shortening communication distance. MEC provides quality of service for latency sensitive and real-time mobile applications. And our next slide is need of task offloading. Okay, what is the need of task offloading? Means mobile devices have limited processing power and battery capacity. We know that, and making it difficult to handle heavy computation locally. Since the mobile devices have limited processing power and battery capacity, so it is hard to handle the computation locally. So executing tasks locally leads to high energy consumption and increases response time, and offloading tasks to edge servers helps balance workload and improves application performance. And our next slide is task offloading concept. Okay, what is mean by task offloading concept means the task offloading involves deciding whether a task should be executed locally on the device or remotely on the edge server. This decision depends on factors such as task size, computation requirement, and network conditions. This goal is to minimize execution delay and energy consumption while meeting a task deadlines. And our next slide is okay. Uh, Wait a minute. Next slide. Challenges in task offloading. Okay. Edge servers have limited resources and must serve multiple mobile users simultaneously. And network conditions such as bandwidth and delay vary dynamically, affecting offloading performances. Okay. Finding an optimal offloading decision is computationally complex and time consuming. This is the drawback of task offloading. Okay. And our next slide is greedy algorithm overview. Okay, what is a uh, overview of greedy algorithm means a greedy algorithm makes decision by selecting the best possible option at each step without considering previous choices, and it focuses on local optimization aiming for immediate benefit rather than global optimality. Due to its simplicity, greedy algorithms are fast and suitable for real systems. Okay, greedy algorithm means it will take the decisions at each step, the best path it will choose at each step. Okay, and it will don't consider the previous steps. Okay, and our next slide is why greedy algorithm for MEC. For MEC systems require quick offloading sessions because tasks arrive dynamically and have strict deadlines. Greedy algorithms have low computational complexity, making them practical for real-time environments. Although not always optimal, greedy methods provide efficient and here optimal solutions in many scenarios. Okay, for quick offloading decisions, greedy algorithm is used in MEC. Okay, and our next slide is system model. Okay, how the system is architecture. Okay, the system consists of mobile users that generates computation tasks and an edge server that process offloaded tasks. Each task has attributes such as data size, CPU requirement, and deadline. A wireless communication channel connects mobile device to the edge server. Okay, and our next slide is each task requires a certain number of CPU cycles to complete computation. Okay, what is a how the task model means each task requires a certain number of CPU cycle to complete a computation, and tasks can be either processed locally or offloaded depending on cost of comparison. The execution cost includes both computation delay and energy consumption. And our next slide is and the current slide is greedy algorithm approach, which means how the algorithm is going to be approached in MAC. It will, for each task, the algorithm calculates the cost of local execution and the cost of loading. The option with lower cost is selected immediately at the execution mode, and a final step is system resources are updated after each decision to reflect current availability, which means, for example, for each task the algorithm calculates the cost of local execution, which means uh, checks the cost of every possible execution and the offloading cost, and the option with lower cost is selected, which means all the possible costs is now the system knows and it will select the lower cost, and immediately the task is uh, at the execution mode, and after the execution mode each system resources are updated after each decision to reflect current availability. Okay, for example, the system resources for a task is done, and it will update the system resources so that the next task can be use the resources efficiently. And our next slide is algorithm working. How the greedy algorithm work means tasks are considered one by one in predefined order or priority sequence. For each task, execution delay and energy consumption are evaluated for both options. The greedy choice is applied to minimize cost without revisiting previous decisions, which means how the algorithm works means entirely the tasks are considered by one, which means uh, no both the tasks can be executed simultaneously. The tasks are considered by one in predefined order, which means uh, one after one, which is already predefined. No uh, intermediate task can be entered in the sequence, and it is predefined order by priority or sequence. Okay, and for each task execution delay and energy consumption are evaluated for both options, and finally the greedy choice is applied to minimize cost without revisiting previous decisions. Here how the algorithm works, the greedy algorithm used in MEC. Okay, and our next slide is advantages and limitations of this method. Okay, and the greedy algorithm is simple, fast, and easy to implement in practical MEC systems. It provides efficient performance with low computational overhead. However, it may not always produce a globally optimal offloading decisions. Here, the advantages are the greedy algorithm is very simple and easy to implement, and also it is very fast. Okay, uh, easy to implement in MEC systems, and it will provide efficient performance with low computational overhead. And there is no overhead while using the greedy algorithm, but there are some drawbacks of greedy algorithm as previously discussed. It may not always produce a globally optimal offloading decision due to the it will don't care about the future things. It only check at present and choose the low cost offloading task and execute the task. Okay, so that there is a drawback. It may not be provide the optimal global optimal offloading decision. And our next slide is Conclusion. In conclusion, we can say that mobile edge computational improves mobile application performance by offloading computation intensive tasks to nearby edges servers. The greedy algorithm provides a fast and simple method to decide whether tasks should be executed locally or offloaded based on the cost comparison. Although not globally optimal, it effectively reduces delay and energy consumption in real-time MEC systems. Okay, I hope you understand, and thank you.